Today we're going to start Chapter 8. Our first lesson will be about the segment and angle addition postulates. I kind of hope that these two postulates, you look at them and think, well, duh, that was kind of common sense. There's postulates that you have been using all along. We just didn't really give them names. So in the geometry terms, they like us to identify a name or a postulate or a theorem for the various things that we do. So if you were ever going to use one of these in a proof, you would be able to have a name for it, like the segment addition postulate, the angle addition postulate, that type of thing. So the segment addition postulate tells us that the lengths of the parts of a line segment add together to equal the total length of the line segment. So there's a picture over here. It tells us if we add the length of AB and the length of BC together, we will get the length all the way from A to C. I hope that's, kind of common to you. So here we're told that AB is 10 and BC is 25, and it asks what's the length of AC. So we would add those two together to get the entire length of AC, and 10 and 25 add together to 35. So AC is 35. Now we should also be able to work then backwards with the segment addition postulate, knowing that we want to find the length of AC, and we know according to the postulate that the length of AB plus the length of BC is equal to AC. So we can just plug numbers in into their appropriate spots. So AB is 21, so we're going to place this with a 21, and then AC, way over here on the other side, the equal sign is 36. I replaced BC just with an X because it's easier to use one variable than the BC. We'll subtract the 21 on each side, and we get X to be 15. So the length of BC would be 15, whatever the units would happen to be on this question. You can also use it with expressions, so it doesn't have to be just plain old numbers. There can be expressions with X's and multiplication, addition, subtraction, that type of thing. So here we have AB is 3x plus 2, and BC is 8x plus 4. And if we want to find the length of AB, is what the question asks, if AC, the whole distance, equals 53. So we know that AB plus BC will equal AC. So we're going to put the numbers or expressions into the appropriate spot. So AB will be replaced with 3x plus 2, plus sign from here. And then BC will be replaced with 8x minus 4. Then our equal sign, and AC will be replaced with 53. And then we'll collect our like terms. So 3x and 8x collect to make 11x, and positive 2 and negative 4 collect to make negative 2. Then we'll add our 2 to each side, divide by 11, and x should equal 5. Now be careful, that's not the answer. The question said find the length of AB. So we want to make sure to plug in. So AB, we were told, was 3x plus 2. We now know x is 5. So 3 times 5 is 15, and 15 plus 2 is 17. And in this case, I do know a label because up here it said AC was 53 inches. So I know AB is going to be 17 inches. I know the label I can use for that. Now the angle addition postulate is very, very similar. If we have a ray, that's OB here, that is in the middle of a larger angle. In this case, the large angle is AOC, the red angle. So if we have that ray in the middle of our angle, then AOB's measure plus BOC's measure are going to add together to give me the length or the measure of AOC. So in other words, this angle part plus this angle part will add up together to give me the entire red angle. You can see a little better description over on the right-hand side with some measures. BD would be our segment that divides up the whole angle. So 60 and 40 add together to give me the fact that ABC is a 100-degree angle. Sorry. So we'll look at the angle addition postulate here. We are told that XLC is 39 degrees and CLV is 103 degrees. So if we wanted to find the measure of XLV, that's the whole big angle, we're going to need to add those parts together. So 39 plus 103 is 142 degrees. So the measure of angle XLV is 142 degrees. Now if I take a look at this diagram over here with some words, It says the measure of angle WVU. So let's find that angle. WVU. WVU. That's the big angle. So we're supposed to find the big angle if the measure of ZVU. Let's trace that again. ZVU. So this side is 62. And the measure of WVZ. One more time. WVZ. So that would be this component is 50 degrees. So the two parts are going to add up to give me the whole. So the measure of angle WVU would be 112 degrees. And I put the 52 or the 50 and the 62 up there for you to see. Make sure you're paying attention to the name of the angle so you know where to place it. You can continue to work backwards here as well. If we know that IJA, so this piece down here is what we're trying to find, and we know AJK, this one right here, is 61 degrees, and we know IJK, so that would be the whole angle, all of it, is 153 degrees. I would suggest you start with labeling what you know. We know 61 and we know the 153. So if I want to find this missing part right here, I need to do the 153 minus the 61, which is what happens when we're solving our equation. And we get the fact that IJA has a measure of 92 degrees. You can also use the angle addition postulate with expressions, just like you can the segment addition postulate. So here, angle ABC is 4x plus 2, and angle CBD is 3x minus 7. Those two are going to add up and give us the measure of angle ABD. So if the measure of angle ABD is 100, find the measure of DBC. So we want this part of it if the whole thing is 100. So these two are going to add together to give us 100 degrees. So we put in the expression for angle ABC as 4x plus 2, and the measure of DBC as 3x minus 7. Add them together to get 100 degrees. Combine our like terms. 4x and 3x give us 7x, and positive 2 and negative 7 give us negative 5. Solve out using our normal solution steps. We get x is 15, but remember, we're not done. The directions were to find the measure of angle DBC. DBC, remember to trace them. DBC, this angle that's marked with 3x minus 7, and we know x is 15, so 3 times 15 is 45. 45 minus 7 is 38. So the measure of angle DBC is 38 degrees. Ooh, now we got a tricky one. I say tricky, but it's really not too bad because we have here this nice little 90-degree angle. So the segment addition postulate tells me that ACD and DCE, these two parts, are going to add up to equal the whole angle ACE, or the whole 90 degrees. So I'm going to put this expression plus this expression and set them equal to 90 degrees. So that's what I've done here. Then we collected our like terms. 7x and 3x are 10x, and 4 and 26 are 30. They equal 90. Subtract the 30, divide by the 10, and we get the value of x, and that's all this one asked for. It didn't ask for anything more than that. It just wanted to know what is the value of x. So the entire key to that question was noticing that we had that 90-degree angle there. So be mindful as you approach your questions today. Be looking for any information that might be a hint to you, that might be in the diagram, but it might not be written in the directions to the question or something like that. You never know where you're going to find a piece of information that will prove to be helpful. So again, as always, let me know if you have any questions or need any assistance. I'm more than happy to help.